Hello and welcome to the Tech Lunch Podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listeners' ears to new and exciting technologies they may have not been purviewed to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello, I'm Nick.
Hey, I'm John.
Hello, I'm Ed.
And, this week we're going to continue on down that 3D printing, I guess we can call it now a rabbit hole, that we're trying to get down the end of it, However, I don't really kind of think you can, there's...
Does it have to have an end?
No. The problem is then we start doing like Disney movies,
Yeah,
and we start back in that little, Mary Poppins type of land,
Yeah.
Spoonful of cheer. But that, we start getting down that random road. And, I think we're really going to start continuing on the, I guess the quality side of the house, but on looking at the difference between, the hobbyist, the what, most people are these days to your, commercial applications, and, how that has, I guess, an impact on different things. So, that's just, one side of the house, but, when you're thinking about that, John, what are you kind of thinking?
Yeah, going into, I love quality, honestly. There's so many things and so many pieces that you can kind of touch on, with, quality of, life, quality of your print, like, there's so many things. But when I'm thinking from a hobbyist side, if I'm not selling these pieces, if I'm not making functional prints that I rely on for, situations that might be dangerous, then I'm actually less worried about the quality. I'm more worried about maybe some of the other things like quantity or things like that. But when I get into it, is maybe I'm thinking about it the wrong way. Is why do I need to be the one impacting the quality and everything that I'm doing with all these test prints? We always want to get to this autonomy, and we're always talking about I have to do this change or this code. Why can't we have? I would like to see the machine work for us more. Ed actually brought a fantastic example of a printer that's like fresh to the market. I don't even know how many are being made right now. But Bamboo Labs made one that's incorporating LiDAR. And to me, LiDAR, like these technologies are so advanced that it's going to get us closer to that. What is it called in Star Trek? It was like
The phaser?
Not the phaser, but it's create, like we were looking at it, creating the food, a particle like
Particle acceleration
condenser or something like that. It was creating the food that they were making, or they would go over to something, press a couple buttons, and like a steak would pop out or something. They would be able to create the food, and not in a sense, or maybe Fifth Element if you've seen that movie.
Yeah,
I guess that was more dehydration, but the same idea is like I've got this material, I want to be able to press play and go, and then it makes the thing while also like
I'm gonna step out here on a limb here and think you're thinking Jetsons.
I mean, honestly,
next thing when you're talking about bubble cars, all right?
No. Yeah, listen, cars that fly. I need you to hear me out.
Next thing you know, we'll be going ludicrous speed.
But yeah, we probably already are. But funny enough, the Bamboo has ludicrous speed on the print head, so that's hilarious. But no, these things that we're talking about, we're touching on the quality of your print, but we can also think about the quality of life of the person who is attending to the farm. So the hobbyist, like if I'm making a farm and I've got 10 printers, like I know 10's a lot, but it's a lot of upkeep. And my quality may be there, but what is the quality of life of the person who has to do the upkeep? And that's why I want to go towards that autonomy kind of mindset. And I think that gets a lot into the industrial side, because what are we working towards every day in production? You want this process to work without don't bother me because I want this process to work nonstop. It needs to be 100% efficient. So like when I think about like the technologies that we incorporate, LiDAR, we were talking about honestly for that bed leveling where they run a couple layers and they even do LiDAR on the layers to see what the printer's flow rate is, or what the hot end's flow rate is. So it's not only is it attempting to level your bed, it's fixing the flow rate of your filament. That is game changing. It's two processes in one. And then when you go into that speed, if you can control the enclosure and increase the speed a bit, your print time for something that's substantially large goes from 2-3 days to 6 hours.
Yeah.
So for me, it's game changing in how fast you're going to be able to print. It's game changing in the quality, and it's game changing on the quality of life of the person attending to those things. So that's kind of one of the things I think about, because it does get, like, my AC broke the other day. I was scared to turn my printer on. I didn't have the full enclosure on both of them. I'm not going to be able to do those things without, a bit of control. And also, because the temperature is so much hotter outside, what's that going to do to my printer? Like, we don't turn on a printer in 80-degree heat, so like it's probably not good for it. So it's probably going to be not good for your print.
Well,
so
the Marine Corps was shipping printers to Afghanistan to print parts for vehicles.
Yeah.
So
I guess it depends on the material you're making, because if you're talking NASA, they're shooting it into space, so they're gonna be making it a bit more robust. Yeah. So
100% infill.
But when you think about that, autonomy is the biggest thing. But what kind of ideas on a commercial level? I guess Ed or Nick, Nick or Ed, whoever want to kind of touch on the topic, industrial side, the quality that would need to happen, or the improvements that would need to happen to maybe some of the printers that we already have in a production environment. Like, you talk about LiDAR, we have a couple enclosures. They put an AC unit in one of them, but is that enough? And what other technologies?
Yeah, that's when you start getting to repeatability. And like we were talking about, making things autonomous, make them work for themselves. And the thing is even your small hobbyist printers can go commercial. It's, and all that is just replacing a couple parts and going from there. It's like we've talked about before, is improvement. We must improve what we have. However, software is going to do that for you 95% of the time. If you set your software up correctly, the software will run your system for you. You don't have to do anything to touch it.
I was going to say, so let me ask you this then. So increasing the software or the firmware, do you think even on a hobbyist level that would be kind of, honestly, we've talked about improvements you make. That should be their first steps.
I would say so.
Yeah.
Because the thing is also at that point you start really dealing with, do I have sensors on board? What type of sensors do I have? Can I take those sensors and throw them into an MQTT interface, taking those and send them from, some of our management softwares that we have out there, the external management softwares that are off printer, and sending those to a cloud-based scenario where you can go back and look at it with Kibana or Grafana or some of those other ones that you want to look at with, and kind of dive into things. Kind of do, you can even throw in a Power BI if you're a Microsoft fan, and really do some preventative maintenance on your printer. So you actually can see if you have a latency in your drives. So if your NEMA 17s aren't spinning at the 1300 RPMs they need to be spinning at, they're spinning at 1250. On one print, the next print you see them run at 1200. They're going to die soon. Now it's time to replace those before they do die and really sticky in the mud later on. If you notice that your print head is getting cooler and cooler and cooler after every single print, and it's not actually producing what it needs to produce, that means that print head's going to die. We have to be preventative in nature. I'm the type of person that's going to tell you that you need to prevent problems from happening, because putting a Band-Aid on it and repairing it later is a bigger pain in the butt than you'd ever deal with a day in your life. And the thing is right now, if you take data from every single data point that you have, you can turn around and make that into something major. And now the LiDAR situation, if you think about that, if I could take that LiDAR and take its measurements, throw it into an MQTT interface and ship it off to something else, now I can actually see what's going on at all times. I know if that bed moves or shifts or warps. Because the thing is, if you tell me that you have 4 points of reference or if you're limited to do something different, you have 8 points of reference, and one of those 8 points of reference is a millimeter off 6 months later, then it's 2 millimeters off the next month after that. Your bed is warping because of heat.
Yeah.
Especially when you start talking high heat applications. It's like, you and me have talked about the OT standpoint. If you start dealing with a non-commercial printer, which you can make, or a hobbyist printer that you can make commercial, and vice versa. However, you don't want to go out and spend the money on a commercial damn printer. If we can start at a hobbyist level, make that commercial, and go that route. However, if you start thinking about it, if you attack from the OT standpoint on that, you start worrying about, measurement drift and pull heights and stuff like that, stuff that you're dealing with, wear speeds. If you think about it, if you can take care of all those, how much faster could that make the preventive maintenance standpoint if data is there for you?
Yeah, I think that if we're talking industrial, when you say industrial means that now I have the advantage of using three-phase power. And the higher the voltage, the lower the current. So now I'm running more efficient with the things that I'm using. So for example, now I can use servo motors. And with servo motors, I get feedback and I'm more accurate. Then I can use, different type of servo drives and things to work with the servo motors. So now I can have those things into a greater tolerance. Far as heating, now I can use, if I have a heating bed, I can control the heating on the heating bed a lot more because I have a lot more area to do those things. And as far as the head, I can have a bigger head. I can increase the size of the head, or I can add multiple heads because now I have those things. But when we're talking about the difference between the two, as far as from a hobbyist point of view to right now, we would say commercial because we're not really at an industrial level as far as what we would call production of widgets. We're probably at medium level. So for example, that would be equivalent to a guy that has a CNC machine that's making some parts for a factory. Maybe he's making 100 of these parts a month. So that would be where you would try to get to, as opposed to having 10, one that could do the work of 10. And the way you would do that, you would probably look at, increasing either heads. I have multiple heads that can work on multiple things at multiple times. Or I would look at increasing the speed without any deviation from printing and print multiple things at one time. As long as I control the environmental factors inside of it. So I would have an enclosure that's closed. I would probably have that heated so that I can control the temperature so that I do not have any deviation between layer to layer. And then the other thing is when we're talking about technologies like LiDAR, or when we talked about technologies, it's not simply put a LiDAR sensor on the end of something and take measurements. It's to have a LiDAR sensor that is in a closed loop system that's working with another sensor, and those sensors compensate. So now we want to compensate. So think of it as I had a thruster, and the thrusters have to be at a percentage. Now I can do things in percentages. Maybe I can do things like predictability. I can predict because I'm taking this information and using MQTT and IoT things and putting it into Mosquito and doing some things with say like Kibana, Elastic, or maybe I'm using Power BI, maybe I'm using Node-RED, whatever system you want to use. But now you can take this data and you can do it. The display is for you. The system doesn't need the dashboard. Right. The dashboard is for you to have all your information in one place to make decisions. Yeah. But what if the machine could take that and that dashboard was something more to the machine, and the machine did some corrections to itself? For example, we was talking about the printer that basically it has some AI where it can identify spaghetti. When you start getting spaghetti in your print, or when you start getting artifacts in your print. What if I was able to say, oh, stop? What if I started to deviate? Stop. Why roll out a whole spool of filament, which is not cheap, and I can just stop and say, okay, we'll just scrap that one. Stop there, and then if you want to override and keep printing, then fine, I give you that option. But I'm gonna send you a message to say, hey, I'm stopping until you make an adjustment. So I would think those things, so some type of assistant that would work with these systems that would take it from hobbyists to, like Nick said and you were saying, I don't have to sit at the machine and tend it. It's not machine tending.
Yeah.
That's not what 3D printing was meant to be.
Yeah, no.
So that's what I think. So what do you guys think?
I wanted to kind of touch on something, and if you wanted to speak on it too, you can, because you showed it to me, and I never really thought about it as much a detail until then, because it didn't quite make sense at first. But we looked at flow rate of not the filament, but all of these printers have an exhaust vent, or like a vent that's or a fan that's cooling down the filament as it's laying down, because it's coming out of the nozzle at about 230 upwards of, depending on what you're printing, close to 300. Honestly, I'm not getting anywhere near that on a hobbyist or like an Ender or Prusa. We're not getting to that point without a couple major upgrades.
Yeah.
But when you get to that point, you need some bit of cooling when it gets to the bed, because the bed is going to be 70. There's going to be a couple hundred degrees Celsius difference between those two, so it needs some type of cooling. It needs something to control that. And we saw something from Siemens that was looking at the fluid dynamics of that flow, because for me, on the hobbyist standpoint, I mean, I have the physics degree. I don't have a fluid dynamics focus, but I can see the merit in understanding the flow of that. So I have an actual, like a physical test where you have different types of exhaust fans or ducts on the hot end, and you put it above, like a petri dish with water, and depending on how deep it could push that water down without penetrating that surface that's how much your blower is going to affect your print. And in that sense, there are a couple. Bullseyes is one of the biggest on Thingiverse that you can get for the Ender, but you can 3D print these things. So that's just the basic idea. For me, the inside of these are hollow because it needs to be hollow for the air to flow.
Yeah.
But what we found with something that Siemens, a program Siemens is running, is they track the airflow, and they can see where more energy is being used to create flow, and it's losing that energy and not getting to where so it's not, let's say it's not 100% efficient in its airflow. But then they modeled they filled in the gaps pretty much where they were having issues, and they modeled a better duct.
Yep.
Same dimensions on the outside. The inside of the duct isn't fully empty or hollow, but it's got some things to kind of help direct that flow. And then they changed, what was it? It was like 22% increased efficiency. Mm-hmm. That's absolutely ridiculous to me that no one's done that before, because these are things that people are just making at the house. So why not run it through a simulation? And that simulation probably ran thousands of times, go into a database with MQTT or something similar that we've been talking about, and it makes that correction for you. So it's making your piece more efficient. That's game changing. I mean, that's, to me, you learn that, you've got efficiency down.
And the thing is, I think if you're starting to do usable prints, and you're talking about, prints that could have a life or death meaning, depending on what they're used for, that's definitely something where, you go really from the hobbyist to the industrial, standpoint because of material. Your hobbyist printer, and we're going to throw this out there because, the last thing we need is somebody saying, well, they said we can do it. No, we're not saying you can't do it. Make something that, on your hobbyist printer, do not try to make something that is, life or death. Please don't try that. No. You cannot do the filament, on your printer at a high enough rate and at the quality that you need that will keep people alive. However, with that, if you're going to build, like flow tables and stuff like that, and you're going to use your 3D printer to print out a diagram of like what you're going to build. Like if you're doing like household piping or something like that, yes, go ahead, print it out. It works. If you're going to say, hey, I'm going to build a oxygen system into a hospital or into a house, that'll be life or death. Yes, go ahead, print that out, test it, and then build it out of full material, right? But if you can take that and throw that in like SolidWorks, if you don't have access to Siemens and X, and you want to go into like SolidWorks and stuff like that and start going through that computational freaking fluid dynamics, you can see how that's going to flow through the house. It's one of those things of where, people should be taking their prints they're doing now, if they want to sell these things and they want to say, hey, guess what? This is what this is going to do. I need to be able to take that into SolidWorks or into AutoCAD, mostly SolidWorks, and throw it through the gamut of being tested. Because SolidWorks will do it for you without even having to print it. By the time you print it, you have the most efficient piece of equipment that you've ever printed. If you don't have access to Siemens and X, which most people do not.
Yeah.
Put it that way. The ability to get SolidWorks and the ability to find somebody who is trained in SolidWorks, especially trained in how to do the CFD and or computational fluid dynamics in SolidWorks is easier to find. I could be thinking outside the box here by saying, hey, guess what? Self-test your stuff before you build it.
Yeah, I think that's going to be the difference between when we say industrial. Industrial means technology that uses powder as opposed to using a wire or as opposed to using thermoplastics or things like that. But I think quality-wise, if we're trying to say, if you're a hobbyist and you're trying to get to, hey, I want to improve the quality, then obviously quality of a resin printer. If you're looking for something aesthetic, is better. But if you're looking for strength, you're gonna want something that's filament or a special type of filament that can do metal or do some type of alloy or ceramics. So it just depends on what you want. If you're looking to play a game of Dungeons and Dragons and you want everything to be nice, Warhammer, you want to paint up the figures or whatever, then by all means go that way. However, but if you're trying to do things where, hey, I have this part on my car, it's not a structural part, and I want to see if I can get better airflow. Or maybe I want to see if I can do something to do airflow with my turbo on my car to get more RPM out of it or something like that. Or, hey, I got these new lights I want to try, LED lights, but I don't want to, pay for a whole nother, lens to go into my car. But I want to just take parts off of this lens and just have a frame that I can put in place just to see what the focus is or the focal point. Then those are the things you would do in a hobbyist environment to improve the quality. Because to be honest, right now it's just toys and widgets and maybe I print a little sign or something. That's mostly what the hobbyist market is right now. It's not like, say, Xerox where they're doing things that are taking powders or taking materials and turning it into metal. I mean, it's like, wow. We're not taking a piece of metal and, subtracting material. We're adding material and making these things. And these alloys, some of these alloys that they're making are really strong alloys. Like there's some applications that people are 3D printing titanium and stuff like that. So for me, I think the big thing when we talk quality between the hobbyist and industrial, that's it. And in industrial also, they control the chamber. They also control the temperature in the chamber. They also can control the wire feed or the filament if they're using a filament type application. They have something that auto change the filament before it runs out. So they don't run into those issues. So I think that's in volume. And to be honest, they can do more volume than, say, a hobbyist printer can do.
Yeah. I mean, you're absolutely right. You actually were just talking about something that I wanted to bring up earlier. The multiple material units, the MMUs. Prusa has one. Mosaic has one. The Bamboo Labs that just came out with the X1 came out has one on there as well. But to me, I think that's an added benefit, and that's an added piece of like how many times can you think of a print or something that's not, maybe it's not one material. Mm-hmm. Maybe it's PLA and PETG not mixed together, but like different parts. Like if you think about a sponge, it's not the same material. I mean, it may be the same material, but it's not the same feel on each side. So you could do one side and it could be a bit rougher, and then on the other side it's a softer material, or maybe a handle and the other side's rougher, and you're trying to like maybe work on something in that sense. So an MMU, to me, yes. I kind of view it as like my next toy, and it's going to be used to develop things that are like probably going to be, you know, color like coasters or things like that, or hell, even I saw, what was it, a flag. They were making a flag in red, white, and blue without you having to do any painting. That takes that step out, and honestly, I would probably trust a 3D printer and its G code in making a perfect star or perfect shape than my hand, because I am a terrible artist. There's a reason why I'm printing and I'm not modeling it out of clay. So yeah, so there's a reason why I use a computer and I'm not writing it with my pen. So
and believe it or not, there's some applications where they use modeling clay for jewelry.
Oh, really?
Yeah, that they're using metallic based modeling clay that they're using for jewelry applications.
Oh, I didn't know.
Yeah, they pour it in and it disappears.
Oh, that's cool.
They also use a 3D printer to print everything out, and you pour it in there, and it melts it out at the bottom of it.
Is it like a
it's a subtractive
acetone?
Yeah.
Like, so they have to.
No,
like...
they pour the molten steel or molten metal into it, and as it goes, you'll see the plastic actually melt out the bottom.
Okay, that's really cool.
So it's pretty much like hydroforming at a certain extent. Usually, a lot of the times they do it when they're doing it inside the sand forms.
Okay. It's the exact same principle.
Yeah, because I was saying with the HIPS filament, it's like it generates the supports, and you do a chemical reaction to melt the supports away. So I mean, it makes sense. I just never knew.
And the thing is, it's like a lot of stuff when you start going into the industrial side of the house from the hobbyist. One thing that can make your hobbyist prints even better is moving away from your standard slicers. I don't want to. Don't build your widget thing, whatever, inside the slicer. Get external CAD software. Some of them are free now to build in. Get in there and try that, because it all starts and doesn't start with just the printer itself or the human being that's operating it or anything like that. It's the software that's used to create the initial model, because the old saying of garbage in, garbage out. If the model is garbage going in, it's going to be garbage on the other side. And the thing is you have a 95% chance you're going to get spaghetti monster on the other end of it.
Can confirm.
So if you start with AutoCAD or Tinkercad or FreeCAD, for that matter, if you're in a Linux-based system, you can go all the way through, and some of them are, like I said, some of them are free, and all of them are web-based. You can do it at work while you're sitting on your thumbs, waiting on your next meeting. Been there. And then, you can turn around and print off the end of the day. You just save it in an STL, load it into your slicer, slice to get the G code, and send it to the printer. Don't touch it after that.
And to build on that, like I said, the beautiful thing right now is the advances in digital photography. And the cameras that we have now are way advanced from what we had back when we had the Polaroids where you shake the picture. Yeah. Now you can take a camera and take 20 or so images. You upload this into a program called Meshroom, and then in Meshroom you can what they call inflate the picture, and then you can export that into Blender, and in Blender you can clean it up, and then you can export that as an STL file into whatever application. So basically you can take the real thing in life, and with a few pictures, you can do 20, but they recommend up to 100. But there's some key things you have to do with that. You have to make sure that your lens focus is the same. You have to make sure that your resolution stays the same. You have to stay in portrait and don't go between portrait and landscape. And then you also have to, pay attention to the orientation of the object, because you would be probably, well, hey, I got the idea to just put it on a plate and let it spin. Well, that's good, but you have to think about lighting and how that'll affect the image. So you just have to take these pictures at different angles without changing the focus of the lens. And what that does is that gives you the opportunity to take something that you would maybe have to author yourself in maybe 2 or 3 days that you can do in maybe 2 or 3 hours, and you would be ready to print.
Yeah.
Well, I just had a quick thought, because I think that that's wonderful, and that's also something that we've kind of been touching on these past couple episodes, because in my mind it wouldn't be like an apple. I wouldn't put an apple down. I want to print that apple. In my mind, a more applicable case would be, I broke this, like, let's say I have a baby gate. My brother has a baby gate, uses it to keep the dogs out. The dogs, they want to get to the other side. They keep nosing it. They keep pushing. That latch snapped. It's plastic. So now I have a snapped piece of a latch on that baby gate. Well, I want to set those 2 broken pieces, or at least whatever I could find, on there, and have it scan that, and then attach those back to each other in an AutoCAD type software. So I'm not saying it's possible. Well, I'm just saying that's what I would be using it for.
I mean, you could, because like I said, basically you would take the image and put them into the software. The software would generate it into a inflate. Basically, it become a 3D object in their file format.
Yeah.
And then you would put it into, say, Blender. And in Blender, you can do these things. You can move these things and even make different layers if you needed to see, how it meshes together. But what I would do is, okay, if you got a camera that, or you have cameras and you have a Raspberry Pi, why not take a little bit of AI and say, hey, I have this image, look at where it's sheared, and tell me where it needs to go back. Okay. And then you take that picture exactly like you said, and the AI fixes it. Just like we were talking about with Siemens, when they took the AI to look at the flow, and it came up with the alternate shape. So you just go backwards.
No, that makes sense. I just saying that's what I would use for a hobbyist side. Like, I see broken things all the time, and I'm like, hey, I can 3D print that. You don't need to buy a whole new anything. I can probably 3D print that piece. So that's just my thought process.
And we'll kind of close it out, for this time around. And we want to take the time saying thank you, everybody who's listening. We're freaking just a couple of dudes freaking talking about the hell we like to talk about, and if you want to listen to us, we more than appreciate it. Honestly, there's more y'all to listen to us now than they do at work. So I want to take the time to say thank you, and to have take that time and go from there. But I want to turn it over to the guys for the final parting shots for the night, and set it off.
As always, we appreciate everybody listening, and we thank you for the support. We'll keep getting on here talking about things that we're interested in, and things that we got ideas about, whether we write about everything or not. We just like to, like anybody else, like to hear ourselves talk.
Yeah.
So
usually.
Yeah, I mean, I agree. I'm going to be honest. Never 100% right about everything. So if anybody listening is wants to even have a discussion about any of that stuff, we welcome it.
Definitely.
Like, please tell us we're wrong, or teach us why we're wrong. That's why we ask these questions, and honestly, that's how we got on these tangents, is because we kept asking questions, and then when both of us didn't, or none of us had an answer, we got to go find the answer. So
we are our own squirrels.
Yeah, exactly. I mean, that squirrel. Yeah, squirrel. That happens like all day. Yeah. So thank you, everyone. Nick's right. They're probably tired about it, hearing about it at work, but you guys aren't. So we'll talk to you more. We'll focus on you guys, and And thanks for everyone for listening.
All right, yeah. Thanks. Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something that you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.